Hello students, welcome to the IMS Get Academy. As part of the foundations course, so from the operating system, I will be taking another topic. The topic name is fork system call. The last session we have seen like a CPU will operate into two modes, user and kernel mode. Also we have seen the shifting process, mode shifting process from user mode to kernel mode as well as kernel mode to user mode we observed. We also understand what is the system call, what is the purpose of system call, what are types of system calls which we observed in the last class. So, from the operating system, 3 sessions so far I have taken. So, this is the 4th session on operating system. So, as I given a schedule also like the various important topic from beginning I will be trying to discuss in the course of operating system as part of the foundation series you can say. Anyway, we have done computer organization also. So, quickly we will move immediately for the topic the fork system call. So, means understand the various system calls we observed, right. The fork system call is one of the process control system call, Let us understand. Let us understand the implementation or working principles of the fork system call. Okay. So, now the fork equivalently we have a create system call in Windows operating system create. It is fork is a Linux based system call. Linux based system call we will observe what the purpose of it, how it is work also we will observe. Okay. The few pointers I mentioned about the fork system call. What is the fork system call? It is Unix based system call. The purpose of the fork is to create a new process. Creating the new process. Yes, I am good ma. How are you? So, extremely sorry due to other tasks the schedule little we postponed, but we wanted to cover the whatever I promised So, due to other works I just postponed today is another schedule try to be part of the session. So, since I said the fork system call used to creating a new process. The creation of the new process, how it is happens, duplication of the original process only, including file descriptors, general purpose register, program counters, whatever parent or current process using, same thing will be duplicated, same set of another set is given to parent new process. The new process is called a child process, means there won't be 2 program counters, but you understand the value will be the parent program counter value only given to the children process like this, you understand. It is like a procedure or function call, like generally in our programming language if you see we use a prototype as a function, somewhere we define, right, jump and will execute, right, method, procedure or function whatever you define, generally we define. So, fork system calls also you just think in that way, but the fork is not going to be executed in user mode. The fork definition is not given by the user. The fork definition is given by the kernel, means operating system. The fork code is available in operating system. So, as I mentioned the earlier class, OS code bound to run in the kernel part of the operating system, kernel mode only it should run, because it is a protected mode. User do not have a permission to run the kernel code see system calls code in user mode. So, system calls system calls are the service which provides the services which provides services from the operating system, is interface I can say is a interface programs through which we can get a service from the operating system. So, this service programs I can say service program, service method, service function bound to run in kernel part of the operating system, that need to be understood. Clear? Please confirm me whether the point is clear or not. Some interesting things we are going to be understand, and also will solve a set of questions also I framed, through which we will understand what type of questions we can expect from the gate, how to tackle them we will observe in this session. The basic idea is clear, the situation understand, application understand. Whenever same task need to be done multiple times, so we can create a process and parallelly or sequentially the process can be run. Let's example, when client server is connected, many clients similar request may given to the server. Now server has to respond all the client in the same way. Maybe data will be different, but same kind of task need to be run. Such cases, server program will run the fork system call to create a multiple process. All this multiple process will respond to the client's request. But the advanced topic, if I want to say, the fork is replaced by the threads. The multi-threading today is we are using what multi-threading for defining this all. But original concept was like fork used to creating a children. Clear? Now, so as we know, function or method, anything you run, we write a return function, returning, right? What function is returning, what return value will be there. Similarly, the fork is a system call which will run in a kernel part of the operating system. It will return something. Return value of the fork system call will be possible, three things possible. It will return 0, the fork system call function return 0 to newly created process, that is a child process we can say. For child process it will return 0. For parent process it will return some positive value. Positive value is nothing but, so new process got created, right? We are naming it a child process. So new process when it is got created, so the process having some attributes like a process ID, process identification number will be there. So that ID is returned to the parent process. I hope you understand. Positive value to the parent process nothing but, what is the positive value? Positive value nothing but process ID only, please understand. Process ID is returned to the parent process, 0 is returned to the children process when the fork is successfully created. When the fork is successfully created, results will be two processes. One is original and the new process. For that new process, 0 has been written. For the original process, PID of the children will be written. In the third case, please understand, whenever the fork system call is not executed properly, if suppose during execution of the fork system call some error happened, so it returns a negative value, indication the fork is unsuccessfully executed. I hope clear these 3 points. The first point I am saying is used to creating a process. Creation of process nothing but duplication of original process, and that's it. Whatever address space of the parent is there, some other set will get it, that's it. In the memory, now 2 programs, so 2 areas will be there. Please understand, 2 area image will be created when fork you run. When fork you run, it will return 3 things, either 0, positive or negative. It's clear? So that will move. Everybody. One example we'll go with the example. Example 1. Look at the example 1. Main printf, in the bracket I mentioned gate. Yeah, tell me now, what is the output we expect? What is the output if I expect if I run in Unix based or Linux based operating system? Try to focus on semantical things, not syntactical things. Semantical things you can understand. If I run this simple code, what is output you'll get? You'll get that's gate only, right? Yes or no? Will print gate or not? Say yes or no. Everyone try to respond. Try to respond. Yes, yes. Is it not output? Will get same thing or not? Yes, we'll be getting gate only. Great, great. Chalo, I'll be adding this one now. Main fork is first line. The second line is a printf gate 2023. The possible questions we expect from the gate examination are previously all previous year questions. When I observe all the previous year questions from this fork system call area, I could able to recollect, I could able to understand what type of question we expect from the gate examination. First question, how many new process created? When we run the fork system call, how many new process will be created? Question number 1 we can expect. How many total output will be printed? Then total number of process executed. Total number of process executed. These are the possible questions we can expect from the gate examination. Let's observe. Let's observe. I said you this is the code, like this is the parent code. This is a parent code, right? Having fork followed by some printf function. But what I said, whenever a fork is encountered, this definition is not available. It has to jump to where? You have to jump to kernel mode, right? You have to jump to kernel mode, okay? You have to jump to kernel mode. That process also I will tell you somewhere fork definitions available. Fork definition available, okay? You have to run this fork, you have to run this definition, okay? Then you have to come back to user mode. Let's take this is user mode, okay? So this one. The jumping process all we have done. So I don't want to take again. So now what I said you fork is successfully executed means it will create a process. Creation of the process nothing but what? What I said you? Creation of the process, just repeat the line. Creation of the process will be dash. Creation of the process will be duplication of the original process. Now see the image. See the image now see. So this we called parent process. This we called parent process. This new process is called child process. Child process. Now see, what is the child code is there? What is the child code? Whatever code available, that only, right? Now there are two processes will be in the system. In a memory, two copies of the memory, two copies of the program will be there having same thing. But you can ask, sir, like duplication of the code will be suppose please understand, duplication of, suppose if I run 10 folks, suppose if we created 10 children, all children is having the same code, right? Yes, same code only. But you can ask, sir, it is going to memory override or not? Yes, sir, it is override only. If suppose by using one process, if you are having many folks, if you create 100 processes, 100 plus one parent will be having same code only. Having same code only. But sir, it is memory override. Yes, sir, memory override. How memory override can be removed? By having a threads. Thread is an advanced topic replaced from the forks. Initially fork used to. Today also like new process when you want to create, we use the forks. But multi-threading is like reduces the what? Duplication of the memories like. But the nature of the fork is that same address space will come here. That's it. So that need to understand. Now questions comes. Sir, question number 1. Sir, among this, which process will start now, sir? Okay, it got executed, like it got fork is executed, children got created. Now, among these two processes, which process will run first, sir? Question number 1. Which process will run first, either children or parent? Yes, it can be. Answer is, it can be anyone. It can start parent, it can start children. That depends on the operating system scheduler. If you are using single CPU, CPU scheduling algorithm will take a decision to schedule either child or parent. Will continue. But who will terminate last? The process which end will be happen by the parent last. All children should terminate first, then parent can be terminated last. This need to be understood very clear. Question number 3. Sir, fork. Very good evening, Dheeraj. Very good evening. When the fork is executing kernel mode, when successfully created, it will return, right? It will return two things. When the successfully created, it will return two things. Tell me, what are the two things? Parent. Yeah, we are right. Parent is the last. Very good. What was my third question? My third question is that when the fork is successfully created, executed, new process we got. What are the return values? For children process, it will return 0. For parent process, it will return positive value. Positive value nothing but parent ID. This need to be understood. So this need to be understood. I shown you. Okay, clear? Child process return value will be 0. For parent process positive value, process ID of children process ID will come here. That need to be understood. Because it is a function call. Like a function call, it will return something. But this function is not executed by the user. It is going to be executed in kernel, because kernel only having the definition of the fork. So dispatch table I shown you also in the last class. If you observe, I shown the dispatch table having the list of fork system call, their addresses where they are available in the main memory, OS part. It will jump there, it will execute, it will come back, and the return value will be 0 and positive. Is it clear? Step number 1, very simple step number 1. When you run the fork, successful execute, 2 duplicate of code will come. Second thing, return value will be 0 for children, positive value for the parent. The third step. So which process can start? Any process can start. Now question comes, fourth question I am asking again. If the children started assumption, if the children is started execution, from which line, which line of the code, children has to start its execution? Tell me, Nishu, Dhiraj and Gate Easy CSE, please all of you tell me answer to my question. Sir, I schedule the children process. From where, from which line of the code, children has to start? Yeah, tell me. I am waiting for your reply. Some more interesting problems we are going to solve. Please stay, all of you, I am requesting. Stay for the session. Definitely, end of the session, you will realize like, okay, I am able to solve the gate question. That's it, like, no. Because gate question not going to be repeated. I am trying to build the foundation to understand and tackle the gate questions. That's what you need to understand. Tell me. From the last line, from the not last line, please understand. Next line to the current execution, next line. See, understand. Fork is created, like, no, return value for fork is 0 happened. The children got created because of this fork only, right? So you have to start from the next line, please understand. You have to write, all of you. Children has to start its execution, next line of the current fork. Next line of the current fork creation. This need to be understand. Next line means next instruction. Next instruction of the current fork, understand. So you know, parent obviously this line is over, second line only, obviously this is normal thing only. So both are having, please understand, both are having program counter value will be same for the children and parent, please understand. Whenever, please observe, whenever fork is encounter, when you jump, program counter will point to second instruction. Now when you create a new children will take register which are used by the parent, it will be duplicated, take the same data. PC, whatever the PC value has, it will take same PC value, so that from there only it will run. Question comes, sir, how children knows that how to run from here only? The fork of the child will be executed. All of you, just you can ask question, sir, how children process knows I should start from the next line from the current fork? How should know? How the process knows? Where we maintain? Very simple. The moment you created nothing but resource also we add. Same resource we have taken from the parent. Program counter, whatever the program counter value of the parent is there, so that will be copied here, so that it will point to that location only. Is it clear, all of you? Is it clear? Because the moment you fetch this fork, when you jump, program counter automatically incremented is point to next line, so that incremented value only we are given to the children process. It will start fetch from this line only. Fork of the child will not be executed, please, because children got created from because of this fork only, right? So children has to start its execution from the next line of this fork, next line of the created fork, next line of the created fork. I hope my statement is clear, all of you. Exactly, that's what I am trying to say. The moment you fetch this instruction, jump here, by the time PC got incremented to next line, that value I am given to the children process. Children has to start from this one. There is no meaning if I again create the fork here, if I run fork here. So that moment you understand, every time new children, infinite time fork will be run, infinite time children will create. Am I right? Suppose you say, sir, fork will be executed. When the fork is executed, then again children will come. The children has to start from the fork only, right? So like that it will be continuously printing, creating the process only. It does not make sense and running of the fork. So this above code you should not worry above code. You have to worry for this line only. I hope these 4 questions are clear. Everybody, because next to all questions are depends on the 4 questions which I discussed just now. Everybody, what about Dheeraj? Get easy. Yes. Everyone clear? Chalo. What the output will print? Suppose if I continue children will print gate. So gate 2024. This will print also gate 2024. So what was there? Yes, this also. Okay. So sorry, but this is the 24. Take it. This printing mistake, because example 2 only I am continuing, right? Example 2 only continuing. Yeah. Question number 1. What is the question number 1? How many new children got created? I'll ask question number 1. If I ask you question number 1, how many new children got created? 1. Question number 2, total outputs are many? 2. Question number 3, total number of process executed is 2. One is parent, one is children. I hope this is clear. Output will be, that's what I know, output will be based on which process you schedule. Example, I schedule the child process. You will run the next line. Here I mention only one line of the code. If you have 10 lines of the code, all 10 lines will complete. Then this will terminate, assumption. Then parent can start, it will run, it terminate. Suppose before children, if I start running the parent all code will run, it won't terminate. It will wait for the process. If process parent, if completed its execution also, it won't terminate. It has to wait for termination of all these children. That need to understand. That's what any process can start execution, any process can complete their execution, but termination of the process will be last by the parent process. That need to understand. Chalo, quickly move to next question. Tell me now, how many new process will be created? How many gate will print? How many total process will execute when I run this code? Yes, everybody take pen and paper, everybody pen and paper, just take this question, attempt it. Try to attempt, try to involve in the class, try to involve. So definitely you will learn something. Yeah. Dheeraj. So Nishu saying that 3 new processes. What about gate easy? IISc. Yeah. Chalo, I'll give some shortcut method like tree method to draw, because sometimes when I increase the number of folks, so then drawing means what you understand, evaluating this code may be troublesome. So let's understand. Suppose I'm taking this is the entire as a parent process, entire as a parent process, right? Entire as a parent process. Now look at parent is here is a parent, okay, parent first line is there. What is the first line? Parent first line is fork. Fork means what I said you. So you observe, yeah, fork means what? Created children. So I'm creating children like this, keeping parent as it is, okay. Children code. What is the children code? Tell me. What is the children code? Yes, what is children code? Whatever entire code will duplicate or not, but short form I will write. To reduce the space, fork 1 followed by fork 2, printf will be there. That's it. Open braces, main function, all will be there. But as a to reduce the space, I written like this 1, 2, printf. Now what I said you, for this return value will be 0. For this return value will be positive. Yes or no? Any doubt here? Tell. Parent started execution, first line it is a fork, create a new process named C1. Parent I kept. I am using the binary tree for evaluating the code. Observe. So I am marking parent, children got. Parent I am keeping as it is. I will be going level by level, left to right. I will go first parent. So now parent, what parent? Parent has to run next line. What next line? Again next line is fork only. So I am keeping parent as it is, I will be creating new children. Let's take children C2. Okay. Now C2 code. Okay, sorry. C2 code. What is C2 code? C2 code is what? Fork 1 followed by fork 2, printf. Yet tell me now. So return value will be, this is 0 or not? This is C2 is from parent only. Return value will be 0. For this return value will be positive. Yes, clear all of you? Yes, is it clear? Is it clear? First of all, is it clear? So now C2 code return value 0. So you should not worry above code. You have to think from here only. If I want to continue C2 should start from here. If If I want to continue C1, C1 has to continue from this line only. That need to understand. So now look at here. So C1 is there as it is. So I'll be taking C1. So C1 as it is. Okay, C1. Okay. Now C1 code. What is C1 code? In the C1 code next line is fork 2. So meaning fork 2 means 1. Again it will create a new process. It will create a new process C3 only, right? So C3. Okay. C3. Now see. C3 code. What is C3 code? F1, F2, printf, right? Printf. So for return value will be 0. Return value will be 0. Now C3 got created from C1. Where is C1 code? Here is a C1 code. Where is C1 code? Here is a C1 code. For this return value will be positive. Yes or no? This line is clear, all of you. This line is clear. When I run C3, you have to run this next line, that is fork. You create a children. When I run C1 code, create a children. So this becomes a parent. This becomes a parent, right? So positive value. So this is children. So we return 0. So now see, I have drawn the now. So one level I feel, right? I'll go next level, left to right. Parent you want to continue. Where parent has to start? Next line. What next line? Printf. So it will print gate. C2. Tell me all of you. Dheeraj, you should tell me, if I run the C2, what is output will get? From where C2 will start? From where C2 will start? C2 code, if you see, left over is printf only. So printf. So printf means what? Gate only. C1 was what? What is C1 code? C1 code is what? Printf only. So this also will print gate only. C3 code. What is C3 code? So next line is printf only. So this also will print gate only. So you are right. Output will be, what is output? Question number 1, new processes. So new process equal to 3, right? Total outputs will be 4 and total process executed. Total process executed is 4, correct. This is correct. Yeah. What you can do, all of you, just I'll give time to you. Just take this example, take this tree. I will give this also, you copy. Yeah, take it. So Dheeraj, do not worry, I'll be using very simple words only. Output can be any order, right? Yes, output will be any order. Absolutely. Nishu is you are right given, no? Absolutely right answer. Output will be any order. That depends on what order they scheduled. Getting what order they schedule. That also depends on CPU scheduling algorithms. Here, since I mentioned gate only one, so that is gate printing, but we won't differentiate. But different output, if we keep it, we can notice what is going to be printed. You are right. Copied? Copy this also. Just important lines, what return values I mentioned, that importance you see. This is 0 return, this is also 0 return, 0 and positive. Printf, third line. 3 types of questions we expect, that also I mentioned here. Clear? Shall we move for next question? Are you ready for next question? Everybody? Dheeraj. Dheeraj, are you facing any problem in the language? आप कुछ problem face कर रहा है? Okay, look at next question. Again, question is simple. Example 4. Tell me now how many new process will be created, how many betweens will print, how many gate will be printed, how many total process execution? Yes. Tell me now. Use the binary tree, all of you, observe, then answer it. All three possible questions. Everyone. Total process 4, great answer, great answer. So new process is 3, absolutely right. Next. What about betweens? How many betweens? How many between? Let's take, suppose again I am taking this as a parent P. If I take parent P here, okay, keeping parent, when I first line fork is there, C1 will get created, C1 get created. So here is a parent, right? For this parent, some positive value will be printed. C1 code will be fork 1 followed by printf, followed by fork 2, followed by printf is there. For this return value will be 0, C1. This is positive. Next, I want to run left to right, level by level, left to right. If parent, if I continue, so next line will be what? Printf only. So it will print between. Okay. Then if I want to continue children, next line, what next line? Printf only. So it is also print between. Okay. One level over, right? Again next level again left to right, parent only. If parent continued, fork is there, meaning the parent will be as it is, new children will create it C2. So C2 code will be fork 1 followed by printf followed by fork 2, printf is there. Look at the C2 code. C2 got created from parent, this second fork only, right? So for this second fork, return value will be 0. For parent, return value will be positive, right? This is done. Now go to C1. C1 code. What is their C1 code? C1. What is C1? This is there. Again, next line you have to run. Fork is there. Fork means create a new process. So C1 as it is going to creating what? C3. Okay. What is the C3 code? Same. Fork 1 followed by printf, fork 2 followed by printf. So this value, return value will be 0. Now see, C3 from C1 code return value will be positive. This need to be understand. Okay. So this need to be understand. Now see. So parent want to continue, this will run here. So it will print a gate. So C2 code, if you see, C2 is last line only. So that is also gate. C1 code, what is C1 code? The last line again, printf only. So this is gate. So C3 also gate. Okay. Now see, total betweens how many? 2 betweens. Observe, 2 betweens, 4 gate, 3 new process. Total process will be 4. I hope this is clear. Everybody, is it correct or not? Everyone? Yes or no? Respond. Nishu. Isaki. Respond. Dhiraj. Chalo. We'll see another question. Look at this question, answer it now quickly. Fork, 3 forks followed by gate. So do not observe the previous example, answer this question. Yes, Nishu Kumar. Dhiraj. Isaki, tell me, what would be the answer? How many new process will be created when I run 3 forks here? when I run 3 folks? Yes, you should answer. You should answer. Respond. Now see, please understand. So we have seen an example. When I run the 1 fork, so new childrens we got 1. Total process will be 2 we got. When the 2 forks I keep in a series, we got, how many we got? 3 got. So total we 4 got. Now if 3 forks are there, what we can expect? Yes, exactly, 7 forks. Total will be 8. Yes, you're right. Nishu, are you getting? Nishu Kumar? So now we can understand one sequence here. Please observe one sequence. What is sequence here? So later we'll observe. Okay. So this is not required, right? So should I require to draw the tree to get the how 7 folks, 7 children? Or you understand? Tell me. Respond, Nishu Kumar. Should I draw the tree for this? Or you got it? Tell me. You got it, right? So answer would be, first question answer is 7 new process will be there. So total 8 processes, and third question is total 8 outputs. 8 outputs will be there, means 8 gate will print. It will print 8 gate modes. Please observe. Okay. Now I'll ask another question. Example 6. Tell me now. Printf IGA followed by 2 forks are there. I am asking in this case. How many output will be print? How many IGS will print? Question is simple. How many IGS printed? Yes. When I read this one, question number 1. Question number 2, new processes how many? How many new processes? How many new processes will be there? 2 forks are in series, definitely new process will be 3, right? Now, how many total processes? So now 3 plus 1, 4. Because 3 children, 1 parent, 4. This is clear. But my question is that how many output will print? How many IGS will be printed? Can you answer? Can you answer, all of you? Yes, respond. Isaki, Nishukumar, Dheeraj, respond. How many IGS will be printed? Answer it. So just make it, this is a parent, okay. So this is a parent process, observe, okay, parent process. When you run parent, first line, what is the first line is there? What is the first line? Printf is there. First line is printf. So now I can mark it. So printf means IGA will print, okay. So no process is creating. One line is over. So now next line from parent only. Fork is there. Fork means what? So fork means what? It will create. So parent I am keeping as it is. So children 1 will create. Children 1 will create. Okay. C1 code. What is the C1 code? C1 code is printf followed by fork 1 followed by fork 2. That's it. Now C1 got created from parent. So now fork only, right? So it will be written 0. Okay. So it will return positive value. That's it, right? Okay, this we know. Next, if I want to go level by level, left to right, again if I want to continue parent, what is the parent core? Parent code is next line. What is next line? Fork only there. So parent would be here only. So children will create it. C2 will create. What is the C2 code? So printf followed by fork 1, fork 2, right? C2 got created from parent because of second fork only. Return value will be 0. This already done. Parent So this written value will be positive only, correct. So this done. Now see, I want to run C1 code. What is C1 code? So it will run from next line only, right? C1 will run from next line. Next line anything, it will create a process. So C1 as it is, it will create a C3. Okay. Now what is C3 code? Printf followed by fork 1, fork 2. C3 got created from C1, written value will be 0. So this written value will be positive. I hope you understand. If you want to continue parent, what the parent code is? Over. C1, C2 code. Where is C2 code? This also over. C3, C1 code over. C3 code over. Right. So how many IGS printed? How many IGS are printed? How many IGS are printed? One time. Yes, you are right. You are right. One time only, right? One time it will print. Is it clear? Now, look the point. Observation. What the observation will do? When the forks are in series, please understand this is a very important line to problem solving. So without applying any tree method, if you know these lines, so this it will reduce our time. If the forks are in a series, if number of forks are 1, if the number of forks are 1, observe, number of new children will be created 1 only, that we know. Total process will be 2. If number of forks are 2, number of new children will be 3, total process will be 4. If number of forks are 3, new children will be 7, this will be 8. Tell me for next. If the number of forks are, yes, answer it. If the number of forks are 4, number of forks are 4, if the number of forks are 4, tell me how many new children will be created? How many new children will be created? Yes. 15, very good. This will be 16. Tell me n forks are there. So 2 power of small n minus 1, 2 power of n. This need to be understand all of you. Is it visible? Is it visible, right? N forks are there. If n forks are there, so number of new children will be created 2 power of n minus 1. Total number of processes will be 2 power of n. Yes. So this observation. Based on this, so there was a gate question. Answer it the gate question. This is the 2005 or somewhere, like they asked question here. 2 marks question they have framed. This question was framed for gate some here. 2 marks. Tell me total number of child process created is dash. For I equals 0, I less than n, I plus plus fork is running. So this for loop is repeated how many times? N times. The for loop is repeated how many times? N times. How many processes will be created now? Option A, n, option B 2 power n minus 1, option B C is 2 power n, option C, D is 2 power of n plus 1 minus 1. Yes, absolutely right. Next question. Please copy. I is repeating n times followed by 4. They are asking number of children. That's it. Copy. Done. Yes. Chalo, see another question. Example 8. This is also 2000, I hope 2020. Gate 2020 or 19 ma. Or 19. This question asked again in 2 marks. Again for 2 marks. Tell me. Again question is what? How many new children created? How many new processes created? Tell me. Int I equal to 0, I less than 10, I plus plus. If I divided by 2 equal to 0, fork, then return. Yeah. Yes. Tell me now, what is the output? What is the answer? How many children will you created here? Yes, absolutely right. 31 is answer. 31 is the right answer. Yes, because how many times this if condition is true? For I equal to 0, I equal to 2, I equal to 4, I equal to 6, I equal to 8. How many times? 5 times. 5 times. 5 times, please observe, 5 times this if condition is true. Means 5 times fork is invoked. This meaning is that one fork is executed 5 times or 5 forks are placed in series. Meaning is same only. 5 forks are placed in series or one is executed 5 times. So, number of children will create at 2 power of 5, 32 minus 1, 31 is the right answer. Yes, correct. Look at this question, interesting question, little modification. Take a question, consider the following code. How many new process created? Same question again. How many new process created? They are asking. Fork and logical AND operator followed by fork, then print gate. Then print gate. Now question is that how many new process created here? Tell me. Yes. So I'll mark it. This is a parent process. Okay, parent process. I will mark this as a parent process. So parent I am taking, parent. Okay, parent. Okay. First of all, to solve this problem, we should know logical operator meaning. Tell me, what is the meaning of logical operator? Can you tell me? Logical operator meaning. And, sorry, I'll take logical and followed by logical or. A, logical and B is there. Meaning, observe. If this is C, please observe. If A is some positive value is there greater than 0. So now we will test what is the value of B, whether the value of B is positive or 0. If A is positive, we will test this one. If A is 0, we won't test the right side operand of the operator. I hope you know, right? Do you know meaning of logical AND operator? If left side operand is positive, then it will check and evaluate the right side operand. If left side operand value is 0, it won't evaluate the right side operand. Please observe. Similarly, A, this is first, this is second. Please observe. A or logical or B. A or B, either A or B, like this to understand. So observe here. If A is positive, please reverse. A is positive, it won't check for the right side operand. He is saying one of them should be true, one of them should be positive. If A is 0, then we will test. When A is 0, it will check right side one, whether right side one is positive or 0. This important thing need to be understood, so that we will come to know whether right side of the fork will evaluate it or not in the code. Observe. Yes or no, all of you? Is it clear? Again asking, AND means both should be true, OR means one of them should be true. If left side is 0 for AND operator, it won't check right side one. That need to be understand. Look at parent. So firstly, here fork will start. Here is fork will start, fork. So parent will be as it is. Now children will create it. Okay, children. Short form I will write. C1 code. C1 code. Fork AND operator fork is there. Followed by printf. Followed by printf. Yes. For this return value will be 0. Yes or no? Because fork created. Fork also duplicated in the children process. So return value is 0. In the parent, this return value will be some positive. Clear? Till this point, clear or not, all of you? Yes, respond. Till this point, it is clear? It's clear? Chalo, level by level. I want to continue parent only. Children got created, but I want to continue parent. But parent next line means what? Next instruction. What is next instruction? Here AND operator is there, right? Here is AND operator is there. You have fork operand also there. Fork need to check. What I said AND operator, left side operand is positive, you check for right side means it is also evaluates in a parent. So now parent will be as it is here, parent will be as it is, now it will create a C2, okay. So now C2 code, observe the C2 code, fork 1 logical AND operator, fork 2 printf. So return value for this is 0, getting my point? Return value for this is positive, please observe, correct? This won't talk, it won't check for this one, it won't check for, because children C2 got created from this fork only, right? Return value will be 0, clear? So now this one, children 1 I want to continue. Where is children 1 code? Children 1 code here. Look at properly children 1 code. AND operator, you see, left side operand is what? 0. It won't evaluate the right side part. It won't evaluate nothing but fork is not going to be called. Fork is not going to be called. Please observe. Because of the meaning of the AND operator. That important point need to be understand. Clear? So means this won't evaluate. I am keeping as it is. Now I'll go to the parent. Parent both done right. What is the next line? This only next line. Printf gate over. So parent part over. C2 code. What is the C2 code? C2 code, see, right side is operand nothing but this is anyway it won't check because it is not bothering the previous code. It start from next line. Now what next line? Printf only. So printf nothing but it will be gate. Gate. C1 code. Where is C1 code? Here is the C1 code. So this part over, leftover part is what? Printf only. C1 printf only, right? Yes or no? Now directly it will print. Here is a gate. Total children how many got created? How many children get created? 2. Outputs how many? 3. Observe. 2 new children's. Total 3 process. 3 outputs we got. This is the observation. Please copy. Yes. Understood, ma? Understood? Chalo, similar question I'll ask. Similar question I'll ask. Tell me now. This code if I run now. Example 10. How many new children will created? Fork R operator and R fork. Fork R fork is there. Gate. Tell me. Yes. How many new children will create? How many new children will create? Everybody should answer it. Yes, ma. What happened? Get easy. It's a key. My dear student, respond. If I run this code, what would be the number of new children will be created? Yes, what is the answer for this? OR operator. See, parent case, this won't evaluate. Children case, it will evaluate. Again, question number 1. So, new process will be 2. Outputs, total output equal to 4. Sir, 3. Output equal to 3 gates. 3 times gate will print. Is it clear? Yes. I hope this is clear. Chalo, we'll move on to another question. Look, this question, answer it. Assume main calls the following function test exactly once. avoid test if fork equal to 0, print gate exit or print 2020. What are the possible outputs? Option A, gate 20, option B, 2020 gate, option C, both A and B, option D, none. Yes, which answer is possible? Which answer is possible? I hope you will answer. Without solving, you will be able to answer it. Tell me now. What are the options possible? What is the possible answer? Yes. Yes, Sesaki, respond. What is output will get when you solve this question? What is output? Observe what I am trying to say. Test exactly once. So the test is calling one time only, they said. Go inside, fork equal to 0. When you called fork, it jump to kernel mode, it create a process. Process means entire thing will create. Let's take it, this a new process got created. Okay. In this case, fork value will be written will be 0, right? It will be written value will be 0. And then you children write written value will be 0. Fork written means, so otherwise you understand. Otherwise understand. This is a parent, okay? This is a parent, right? So what is the child will be? Child process would be y test y type if fork equal to 0, print gate exit only, right? Exit 0. Close. Here is printf, right? Here is printf. Printf 2020. This is child code. Child code, right? This is the parent. After child creation, this value will be positive value. Return value is positive, right? For this return value will be 0, right? Suppose if I want to run parent, what happened parent? Positive value equal to 0, will it be match? So condition get fail, right? If this condition is fails, so can I run print this one? It won't print. It will print what? 2020. Output of the parent is 2020. Now output of the children, what happens? Return value 0, 0 equal to 0. Condition is true. If this condition is true, nothing but printf gate. So it will print gate and exit. We are exiting here, only exiting. Gate will print. Children is printing gate, parent is printing 2020. What is the order? What is the order of printing will happen? It can be a 2020 gate or gate 2020. That's what I said now. Parent can start first execution or children can start for execution. Order will change. What order possible? Gate 2020 possible, 2020 gate possible. Hence, option C is a suitable answer. Option C is a suitable, not answer B. Because 2020 gate, when you run first what? Parent, then children. When you run first children and then parent, this is possible. That's the reason option C is right. We can select. I hope this is clear. Yes, is it clear? Is it clear? Similarly, I'll take another question. Look at this. Little again increase this efficiency, you understand. Fork AND operator followed by logical OR operator. Then print gate is there. Again, we are asking how many new process. Can you answer it? Can you answer it? How many new children will be created? Tell me, yes. Use again, simple thing, use the concept of the tree method. You will answer it. So start from parent. Parent start first fork, right? First fork. So I am keeping parent as it is. So children will, C1 will start creating. C1 got created. I'll write the C1 code. What is C1 code? Fork. I'll write short form only. Fork 1, logical AND operator fork 2, OR operator fork 3 is there. Followed by printf is there. Return value will be 0. Yes or no? For this return value will be, where is here is right. For this return value will be positive. So I should write here, right, C1 code, fork and fork 2 or fork 3. Return value will be 0, parent return value positive. So this strike out. Sorry ma. Chalo. Now look at this one. If I want to continue again parent, level by level, left to right, parent I want to continue. What I say to parent? Parent, you see next is what? Logical AND operator is there. Next is what? Logical AND operator is there. So left side already evaluated, we got a positive value. We should evaluate right side part compulsory, you should evaluate. Evaluate meaning what happens? So parent will be as it is, fork will run. When fork will run, it will create a C2 children 2. So now children 2 code will be followed by printf will be there, right? Now fork 1 and fork 2 or fork 3, printf is there. So this return value will be 0, right? For this return value will be positive, return value will be positive, that's it. So I'll go and see the children code 1, children code 1, children code 1. So children code 1, what happened? So left side is what? Left side is what? Tell me, left side is what? 0. Meaning this won't evaluate as per the AND operator. This won't evaluate. So this is not going to be evaluated, right? As of now, it is not evaluating. Let's see next part. So now I am keeping as to C1. Then I move on. This part over, right? So this nothing is printed. I'll go level by level. This level over. So I'm marking from parent. Parent want to continue. What parent will do? So it was evaluated this line over. So next is logical operator. What logical operator says? If left side part is positive, right side won't evaluate. So now this fork is not going to be evaluated by the parent process. Since logical OR operator left side, if see both operands were positive, so it won't evaluate right side one. Clear? Parent won't do anything. So next, if you want to run, this can run next line only. Then go to C2 code. C2 code. What is C2 code? C2 code. What is C2 code? Here is a C2 code. See. So we won't bother this part. We won't bother this part. We bother this one. Left side operand is what? 0. What logical OR operator says that? If left side operand is 0, you have to evaluate right side one. Meaning you understand now. Meaning you understand. Which code we are checking? C2. C2 code we are checking. So C2 will be as it is. Parent, this is the parent. Now it will go to create a C3. Now C3 code will be fork 1 logical and fork 2 or fork 3. So printf. C3 got created from C2. Which fork we run? This we run. For this return value will be 0. For this return value will be positive. Positive. This way we understand, right? Now look at. So C2 run C1. Before evaluation not there, then you can think now C1. So where is C1 code? This is not run. 0 was there, left side operand is 0, right side is not evaluated, right? Next you have to logical OR operator is there. Logical OR operator is there. As of now this is 0 only, right? As of now this value will be 0 only. Logical OR operator is there. So you have to evaluate this one. You have to evaluate this one. So now see. So children will be, so this parent C1 will be as it is. It will create a new fork, new system called, new process called C4. C4 will create. C4 will create. So now C4 code will be same fork 1, logical AND operator, fork 2, or fork 3. So printf is there. For this return value will be 0. C4 got created from C1. So this is positive value will be printed. This level is over. This level is over. Okay. Now I have to go to parent. What is the leftover line? Printf function only return. So it have to print gate. C2. What is the C2 code? C2 code leftover, that all lines override. So printf only. So this also printf. C3 code. What is C3 code? C3 code here. This part, this is the printing, right? So next line is printf only. C3 also gate it will print. C1. Where is C1 code? This already evaluated. This is what? Printf only. C4 code. C4, this line over nothing but next line only, right? Leftover part. This is only, it will print gate. Total number of children got created 4. Total 4 new children got created. One is parent. Total 5 processes. Total outputs are again 5. 1, 2, 3, 4, 5. 5 gates. Yes or no? 5 gate will print. Clear? Is it clear, ma'am? All of you. Is it clear? Now similarly, one 2017 paper there was a question. Yeah, good question. Answer it. Answer it. Consider following code. If fork and fork, if condition is true, then run one fork. If fork or are 4, this condition is to run 2 forks. Print gate 2017. How many times gate 2017 is printed? How many times gate 2017 is printed? How to answer this question, sir? Because if you want to draw a tree for this one, it is going to be lengthy, big. Then what I will do? You see, if function is there, this is the if function. You see, if function. If this condition is true, this will run. Till this, some process, new process and parent process will be there. Every process has to run this code or not. Okay, suppose let's take this code. If I run, let's take 3 children got created, 1 parent is there, assume that. If I run this code, this part of the code, 3 children created, 1 parent is there. All 4 process has to run this code or not? Tell me, just tell me, confirm me. all 4 process has to run this part of the code or not? Because every process when you create an entire code will be duplicated only. But these lines need to be run or not? Respond, everybody respond. So now when you invoke this one, parent will create 1 children. Then hand operator, again parent will create another children 2. In a children code, what happens? So that won't execute it. Condition is false. Parent code, this condition is true, right? This also will run fork. Meaning you understand. Total 3 children. When you run this 3, parent plus 3 new process will be created. Total 4 process will be there here. Yes, you run. Please trace out. You will get same thing. When you run this code, parent create a new children. Return value positive, so that you are evaluating the parent process. You also create another process. So both are positive means condition is true. Again you create a children. With total 3 children created by a parent only. In a children case, condition is going to be false. They won't create this one. That's the reason 3 new children created by parent. Total 4 process will be there. End of this code. All 4 process has to run this code. What you can do? Individually you run this one. This how many it will create? How many this will create? So now please understand, total number of process including parent, I am telling you 4. Okay, 4. Each process will create a 9 please observe, 9 process will be there here. So 9 you have to evaluate. So total 36 will be the answer. Verify after the class. I am requesting everybody run this code ma. Just verify. Answer I am giving you 36 as you have to be practice. So you run this separately as by using tree, apply the binary tree, you will be getting 8 children, 1 parent. Here is 3 children, 1 parent. All 4 process will run this one. 4 into 9, 36 process will be available. 36 printouts will be there. 36 times gate 2017 will be printing definitely. Is it clear? Is it clear, ma? Yes, respond. So the concept is clear. First of all, how fork is running, then how you are tracing, how you are evaluating the tree, so that you understand. So this foundation is enough to solve the any type of gate question which they frame from this topic. So we can expect 1 mark question or 2 marks for question from this topic. Most of the time happen 2 marks. Sometimes even they frame from 1 mark also, but 1 or 2 marks we can expect from this area. If this is clear, chalo. So I'll be stopping the session. In the next session, we'll start process management. There we'll understand very clearly process. What is a process? What is a program? Differentiation, various states of a process, various schedulers. So the basic building of a process management we'll study in the next class, so that upcoming session will be easy. Yes, is it clear? Chalama. Thank you so much. Thank you, ma. You apply, like next class I'll ask you, just you work out, you just tell me next class how you got same answer or not. Yes. Chalama, we'll meet into next session. Thank you so much. I'll be stopping the session.